Okay, let's look at the second FRQ. This says find the values of A, B, C, and D such that this function has a relative maximum at 2, 4, relative minimum at 4, 2, and a point of inflection at 3, 3. So let's kind of list out what all of this means. We know that our equation that we're going to start with is ax cubed plus bx squared plus cx plus d. So there's where we're going to start. They have told us that we have a maximum at x. Let's look at the x values first. A maximum at x equals 2 and a minimum at x equals 4. And we have an inflection point, so a point of inflection at x equals 3. So let's think about what this means. This is f of x. This is f prime of x. And this is f double prime of x. And when we have a maximum and minimum, to get them, we take the derivative and set it equal to 0. So this is when the derivative is equal to 0. And this is when the second derivative is equal to 0. So let's take these functions, and I'm going to apologize ahead of time because this does take a lot of paper space, so I do not think that you have enough room. I didn't have enough room on my packet. So if you want to get another piece of paper, now's the time. So what we want to do is we want to take all these derivatives. So let's go ahead and write our original function. So we have f of x is equal to ax cubed plus bx squared plus cx plus d. Okay, and then I'm going to go a little bit down and I'm going to write my derivative. So where I can still see maybe, let's look at our derivative. I'll get a new color. F prime of x would mean we're just going to bring the 3 down. So we have 3ax squared plus 2bx plus c. The derivative, remember d is just a number. So the derivative of d, nothing. Now I'm going to go a little bit down again. And I'm going to take my second derivative. So my second derivative, double prime of x, is 6ax plus 2b. Okay, so this is everything that I found so far. Now let's go back up. Let's start at the end and work our way back. Let's look at our second derivative. When our second derivative is equal to 0, we can plug in 3 for x. So let's go back down to our second derivative, set it equal to 0, and plug in 3 for x. That means we're going to leave the a and the b alone. We don't know what those are. We only know what x is. So this is 6 times 3, so we have 18a plus 2b. Now here's where we need to make our decision, because our goal is to get this in one variable. Because we can only solve, once we get one, we can get all the others. It's like a domino effect. But we can only solve an equation for one variable at a time. So the one variable, I guess I should spell that right, the one variable that I'm going to choose to get everything in terms of a. So that means I need to get b equals something with a in it, and I'm going to get c equals with something a in it, and d equals with something only a in it. And then I can solve an equation with only a, and then I can use a to find everything else. So let's do this. Let's subtract 18a. So we have 2b equals negative 18a. Now we'll divide by 2. So we get b equals negative 9a. Okay, So we will take this. This is the first thing that is important. Now, you cannot plug this back into the equation you got it from because it'll just give you 0. So every time you get an equation like this, a constraint, we can call it, you have to take that and put it in a new equation or else it's not going to help you at all. So we need to take that, let's go up one, b equals negative 9a. We can take that and put it here in our first derivative. So b equals negative 9a. So first we want to get rid of x. For our first derivative, we know that we can plug in 2 or 4 and get 0. I'm going to plug 2 because it's smaller, because we have a maximum at 2. So plug in 2 for x and set the equation equal to 0. Plug in 2 for x and set the equation equal to 0. Oh my gosh, I never get this done. Okay. Undo that. Okay, 0. There we go. That's our original. Goodness, this computer. We're going to our derivative. Going to go to my derivative. I'm going to set it equal to 0. I'm going to plug in 2 for x without my computer freaking out. Okay. Beautiful. Plus 2b, instead of x, I'm plugging in 2, plus c. So we have 3 times 4 is 12a, 2 times 2 is 4b, plus c on the end. And remember, my goal is to plug this in. So I'm plugging b equals negative 9a to get rid of b here. So 12a is 4 times negative 9a plus c. So we have negative 36. 12 minus 36 is negative 24, a plus c. Let's add that and we get c equals 24a. Now I have c in terms of a. I have b in terms of a. Now I need d in terms of a. Because remember, I'm choosing a to be the variable that I'm getting first. There's b, there's c. I need to go to the original to do d. What I know about the original is I know that if I plug in 2, I'll get 4. If I plug in 4, I'll get 2. If I plug in 3, I'll get 3. That's what those ordered pairs mean. That's where that y value is going to come into play. So I'm going to start with 2 and 4. This will equal 4 when I plug in 2. So I'm going to have a times 2 cubed plus b times 2 squared plus c times 2 plus d. Remember, my goal here is to get d alone, but I need to multiply this out. So I have 2 cubed is 8. 2 times 2 times 2 is 8a, plus 2 squared is 4, 4b, plus 2c plus d. All this is equal to 4. Okay, so let's go get those things that we found. We know that c is 24a, and we know that b is negative 9a, if my computer would work. Oh my goodness. So b is negative 9a, c is negative 24a, so let's plug those in. A is a, b is negative 9a, c is 24a, plus d. Now I want to get d alone. So I have 4 equals 8a minus 36a plus 48a plus d. So keep in mind you don't have a calculator for this problem, but we can think this through. 48 and 36, the difference between there is 12. So we have positive 12 plus 8, and we get 20a plus d is equal to 4. We're trying to get d alone, everything in terms of d. So d equals 4 minus 20a. Woohoo! Everything in terms of a. Great. So we've used this equation. We've used this equation. We have used this equation. We need a new one. So there's two more that we have. We can do our original equation. We can use our original equation with either this order pair or this order pair. I chose to use 3 and 3 because I thought 4 was just a little bit too big to plug in. It doesn't matter what you use, you will get the same answer in the end. So we're going to take our original. It's going to be equal to 2, or we're using 3, sorry. It's going to be equal to 3 when we plug 3 in. So it's going to be equal to 3 when we plug 3 into our original. So we have a times 3 cubed plus b times 3 squared plus c times 3 plus d. Okay, so let's multiply that out. We have 3 equals 3 times 3 is 9. 9 times 3 is 27. We have 27a plus 3 squared is 9. B plus 3c plus d. Whew. All right, so we have a. We're going to make all of these a. B is in terms of a, C is in terms of a, and D is in terms of a. So our equation becomes 3 equals 27a, A is already a, plus 9 times b. B, if we go down here, b is negative 9a. So let's plug that in. Negative 9a plus 3 times c. C is 24a. So let's plug that in. And D, all by itself, 4 minus 20a, little a down there. So we have 3 equals 27a minus 9 times 9 is 81a. 3 times 24 plus 72a plus 4, so something without an a, but we can move that over, minus 20a. So let's go step by step here. These numbers are kind of big, but we can do it without a calculator. It's okay, don't freak out. Okay, so we know that this 4 can be subtracted over. So that can be a -1, so we're done with that. So I would choose numbers that are closer together. We have 27a minus 20a. That's going to give us 7a. And we have negative 81 plus 72. So the difference between 81 and 72, if we count up from 72, is 9, and 81 is negative. So we have minus 9a. Yeah, that's right. And then we can do that. 7 minus 9a is a negative 2a equals -1. To get a by itself, divide by -2. So a is 1/2. Then we can use this to figure all of the other ones out. D is right here, so we can do D first. D is 4 minus 20 times a, and we just figured out a was 1/2. So D is 4 minus half of 20 is 10. So D is -6. That's nice. Then we can use our 1/2 and plug it in for C. C is 24 times A. A is 1/2. C is 12. And here, B is -9 times A. A is 1/2. So we have -9/2. Woo! So let's write that all together. A is 1/2. B is -9/2. C is 12. And D is -6. So if they wanted to, they just asked us for those four. If we wanted to write it back in the equation, it would be 1/2 x cubed minus 9/2 x squared plus 12x minus 6 is our original function. So that was just a lot of algebra. There we go.